name is Jennifer Winkelman, and I'm doing this Math 111 Test 6 review. This entire test is over rational expressions, and again, as I tell many students, the best way to study the math is by practicing it and doing it on your own. You can use this video as a resource, the review that I posted as a resource. Try to work it on your own, watch the video for help, go back, get those answers, and then try to do it again, as many reviews or as many problems as possible, so you can get the right answer. Okay. With rational expressions, what we're usually doing, multiplying, dividing, adding, subtracting, reducing, and then we do a little bit of solving later on, okay? But right now, let's go ahead and get started with reducing this to lowest terms. And so, in this case, we notice that all of these have an x in common. All right, not all of them have a 5. 2 of them have a 5, but not all of them do. So let's go ahead and factor out what they have in common. So I can factor out an x from the top, and I have an x and an x and a 5 left over, okay? And then over here, if you want, you have this x, like times 5. Kind of write it like that. So it shows that I'm trying to get rid of something that they all have in common, okay? And you're thinking, why isn't it just 5x? You can do it that way if you want. But for some people, it's easier to do it this way. Now, you cancel out the common x, and then now you try what's left over, x plus 5 over 5. Now, you might be thinking, why can't I do this? And my answer is just x, or x over 5. Well, that's not the case, okay? If you want to try to reduce this further, you might be able to, but that's not really what they want in this test, okay? If you can leave it like this, that's an answer, that's cool. If you really wanted to, you could break it up and do x over 5 plus 5 over 5, and then reduce them separately, but notice they both have a denominator of 5. You can only do this if this term is a plus or a minus, and you have a single term on the bottom. If you had something like x plus 2 on the bottom, you couldn't do it. You couldn't break it up like that. You couldn't have x over x, 5 over 2. It's not going to work, okay? Now from here, x over 5 can be changed, but 5 over 5 reduces to 1. So you can write it like that. But really, this one right here, that's what your teacher expects in their answer. Leave it that way. Don't have to do something fancy. Okay, this next one says reduce to lowest term. So we're looking here. We see some stuff. We're going to do some factoring. Let's factor, see if they have any common terms. Usually cancel something out. Factor whichever one is easier first, because that'll help you factor the next one, because you already know that you're looking for one of the two answers. The top is pretty easy. We see it's a plus-plus situation. Okay. Ways to get 15. 15 and 1, 5 and 3. 5 and 3, they add to get you 8. Okay. So now I know for this next one, I'm looking for one of these two factors that I just wrote down. Well, this is x minus 9. That's a difference of two squares, which means it's going to factor into an x and an x and a 3 and a 3. One's a plus, one's a minus. Now we notice that this is the x plus 3 and the x plus 3 is what they have in common. Cancel it out. Whatever's left over, x plus 5 over x minus 3, that is your answer. Now, the next one says find restricted values for x. If there are none, write no restrictions. Restricted values mean what's going to make this denominator 0. Remember, we cannot have 0 in the denominator. That makes it an undefined problem, okay? So we're trying to avoid that. So any kind of case where we have an x or an x squared or something like that in the denominator, we need to see what numbers will make it 0. Sometimes nothing makes it 0. I'm going to show you an example of that in a minute. Let's go ahead and find this one. Nobody cares about the top. Don't care about the top. 4x squared. I don't care that x equals 0. No. It doesn't affect the denominator. Only look at the denominator. So 9x minus 9, set that equal to 0, and then just solve for x. Add your 9. Add your 9. 9x is equal to 9. Divide by 9. X is equal to 1. So this is what happens here. Okay, so then your answer, this is the restriction. You could say that, or you could say x cannot equal 1 using that equal sign with a cross through it to show that that is the restriction, okay? So either way, that would work. So you could write your answer like this, or like the one that I circled in blue. Now, you're like, when is there a possibility whenever there is no restrictions on the denominator? Well, if you had something like x minus 5 over 2, any kind of number, just a number, no variable, then this would have no restrictions. That's an example of that. Another case, you might not believe me, is if you had something like, x minus 7, even x squared minus 7 over x squared plus 3, right? X squared plus 3 is never going to give you 0. If you plug in 0 for x here, you get 3. If you plug in negative 3 or negative something, it's always going to get squared, it's always going to become positive. So you can only get positive numbers down here, all right? So it's never going to become 0 in the denominator, so it won't be undefined. So these are two examples of something that would be no restrictions, all right? This one says find the least common denominator. They don't want me to solve, they don't want me to add or subtract, I don't have to worry about any of that. I just need to figure out between these two what is the least common denominator. If I were to add or subtract, I would need to find. Well, look at their denominators. X squared and 3. You need to see, do they have anything in common? If it was something like 24x and 6x squared, well, they have an x and they have a 24 and 6 go into each, 6 goes into 24, okay? In this case, this first one doesn't have any numbers and the second one doesn't have any variables. So they have nothing in common. So what you just end up doing is multiplying them together, 3 times s squared. 3s squared, this is your LCD, your least common denominator, okay? So what was I just talking about? Well, what if I gave you something, like let's just say 3 over 24x and then y over, like I said, 6x squared, right? Well, finding the least common denominator here, because 6 goes into 24, 24 will be your number, all right? It's not going to be bigger than 24 because 6 goes into that, okay? And they have an x squared in common. They have an x squared as the biggest one. So again, least common denominator is least common multiple. So if you have something that goes into something, like 6 goes into 24, you pick that number, the 24. And you have x and x squared, you're going to have to pick x squared, all right? You got to find what they need to get to, not what they already have. All right. Let's look at this next one. This one says perform the indicated operation. So we're adding or subtracting here. In this case, we're subtracting. If you look at the minus sign, they both have the same denominator. I don't have to find one. So I'm just literally adding and subtracting the numerators. So I rewrite out the numerators. Now this minus sign here needs to be put into the 6x and the 7. So you go ahead and you distribute it. Okay, and then this is all over one big denominator now, that's all right. I'm putting this in, I get 8x plus 9 minus 6x minus 7. 8x, all over x minus 9. 8x minus 6x gives me 2x. 9 minus 7 gives me 2. All over x minus 9. Now you might be thinking, I can take out a 2 from there, they both have a 2 in common, but you can't cancel anything, so leave it alone. Okay. Now the next one says we're doing the same thing, but we notice that they have two different denominators. Well, in this case, you need to find the LCD. So I'm looking at this. You see one's x squared minus 4, so you're thinking, let me see if I can factor. First thing you want to do is if you have something that can be factored, do it. X squared minus 4 is the difference of two squares. We saw one of those earlier. X plus 2, x minus 2 is how it's factored. Plus 4, x plus 2. Now we notice that this one, just like that previous one, not here, but here that I showed you, you see how this had x and x squared, we took the bigger one, okay? So I'm looking here, this one has an x plus 2. This one has an x plus 2, but this one is missing the x minus 2. So your LCD are going to be the two of them together, x plus 2 times x minus 2. Now, here's the deal. This already has them both. I don't have to do anything to that fraction. Okay, but I am missing the x minus 2. So I will multiply the numerator and denominator by that. And then that will get me my new one. So I end up with 3x squared all over x plus 2, x minus 2, plus 4 times x minus 2. I'm not doing it just yet. All over x plus 2, x minus 2. Okay, don't think you could cancel those or something. We're doing this so that we can add and subtract them. Now, I can go ahead and combine them under 1, x plus 2, x minus 2. and I distribute this in. So I end up with 3x squared plus 4x minus a. Now, can't combine anything, all right? Everything on top is the same. You can look at this, see if you can factor it, but I already went ahead and tried, and you cannot. Okay, but in some cases you might be able to factor this and then cancel something at the bottom. Always double check that you need to try to do that, because maybe you could cancel one of the factors. In this case, this top is not factorable, all right? And it's because it's not factorable, then we don't even want to try to do that. But you might want to try, if you notice that it's factorable, so that, you can possibly reduce it further. Okay. I'm going to stop here, and then we'll continue on.